Consistent hashing. Hi guys, my name is Manish Kumar, and in today's session we will talk about what is consistent hashing. Basically, we are like in every system design, we are talking about it. We are saying the database or memory is distributed across the servers. So how that entire distribution is happening, how the data is broken into small chunks and distributed in different servers. So without any delay, let's start the session. See you in the session. Hi guys, welcome to my channel, and in today's session we will talk about consistent hashing. So let's before going into consistent hashing, let's talk about scaling first, because then we will understand this better. So scaling. So in today's world, we have we do generally two kind of scaling: horizontal scaling and vertical scaling. So let's first talk about vertical scaling. So vertical scaling is, for example, you have a computer and that computer has, let's say, 4 GB RAM. You are working on certain application and you feel like your system, your memory always like, crashing, or you are facing problem of shortage of memory. So what you gonna do? You will just raise the IT ticket and you will say like, hey, I need a bigger system, which is like maybe 10 gig RAM. So what you are actually doing here, you are actually scaling vertically the server or your system. So adding CPU, RAM or disk in the server is called vertical scaling. It has its own limits. You cannot go infinitely increasing capacity of a server. Now we come to horizontal scaling. Horizontal scaling means that you are working on a system, you have 4 gigabyte RAM, and now you feel that I need additional RAM. So what I should do? Let me bring another 4 gigabyte RAM and divide my workload into both servers. So now I have 8 gigs RAM, 2 CPUs, 2 disks, and I divide distributed workload among these two servers. Similarly, I need more, I go more with the more servers. So basically, adding more servers and distributing load among them is horizontally scaled. And that is the most popular one in today's distributed systems, because we can increase our number of servers as per our need. So this is better, and we are not bound with a hardware limitations and all the limits we were struggling with in vertical scaling scenario. But the interesting thing we said here, distribute load. So how you distribute load? Let's say you have a big database here, or like something you were storing in the memory. This is like a big data. I'll say large data set. And now because you have two servers, what you do, you actually split it into two database. The same large data is DB1 and DB2. So now your server 1 is having, in the RAM of server 1 you are having DB1, and another you are having DB2. So this data is stored there. Now you further get more servers, you divide the data further more into servers. So it's working like this. So now you have DB1, DB2, DB3. So you see, like the big data you broke into multiple chunks, and you have now a good system which is like distributed. But as the first thought comes here, how I broke the data into this, how I distributed the data among servers. And if let's say one server is down, how where that data will go? All those things are coming to head, and that's what we're gonna talk. That's where the consistent hashing comes in the picture. So now you know how horizontally scaling work, and now we just break down or like split the data into chunks and distribute it among the servers to uniformly distribute the load. Now let's come back to our mechanism how we will distribute this data. So I'm taking an example here. Let's say we have a database having 10 keys, key 0, key 1, and up to these key 0 up to key 10 in the large database. And in our example, let's say we have 4 servers. So how we will do it? So there are different mechanisms. One mechanism or one algo is like having a traditional hashing. So what it will do, it will hash key, we will run a hash function on each key and will perform a modular operation n. And what is n? N is the number of server. So how it will work? It will take key 0, hash key 0, a numeric number came up, we perform a modular 4. So if the result is 0, then it will go on S1. If it is result 1, then it will go on S2 and so on, S3, S4. And let me write this down and I'll be back. So here you can see these key 0, key 4, key 8 is on server 1, 159 is on a server 2, and 2610 is on server 3, and 37 is on server 4. So entire load is distributed among servers and everything is good. But the challenge comes here is, let's say if server 3 is down, let's mark it something on this. So let's say server 3 is down. So what clicks right away here? That key 2, key 6, key 10 need to move to some other server. But if you will see the algorithm we are using here, algorithm is saying hash key and modular by n. Now n is 3, it's no more 4. So what we need to do, we need to actually remap the entire data set. We need to remap again all the keys. So if we will do it again, then you will see key 0 is on server 1, key 1 will go on server 2, and key 2 will go on server 3. Now key 3 will go on server 1 and so on. So actually we have to remap the entire data. It's a big challenge, almost impossible to remap everything without taking our system down. So to handle this use case where we can avoid this kind of scenario where we have to rehash the entire data set, what we have another approach, and that is called the consistent hashing. Consistent hashing helps here and handle this scenario effectively. How that works? Let's talk about that. So how consistent hashing works? Consistent hashing, let's say here we use SHA-1 hashing, which ranges like from 0 to 2 raised to power, I guess 160 minus 1. So this is a hashing what we're going to use for this. So what we have, our hashing will give us the keys beginning from 0 up to 2 raised to power 160 minus 1. So these all are the key slots we have available. Now our data will come, we will pick a slot, the right slot based upon their hashing value and put it there. So now let's see how it will look like. So let's say we have a hashing key space. So let's say we have a hashing key space here, and all these 0 to 2 raised to power 160 minus 1, all these keys are distributed on this space, like they have slots for each key on this, something like this. So let me draw it for you and then I'll be back. All these slots are there, key 0, key 1, key 2, and up to 2 raised to power 160 minus 1. So that's how the keys are distributed. And it has both ends. Let's say, let's just give a name for these. This is, for example, maybe left hand and then right hand of this space. Now, what happens to make it as a consistent hashing ring, we need to join these right and left hand together. And what will happen? It will turn out to be a ring of keys. So all these keys will be there. Only thing is that left and right will join and it will become a ring. So let me draw a diagram for you and I'll be back with it. If you will see, it was a space here. Now we joined right and left ends of this and it turned out to be like this. Key 0, K1, K2, and all up to K2 raised to power 160 minus 1. So we have the ring in place now. Now we have four servers in our example. So those four servers are also placed on this ring. So let's say something like this. Here is server 1, here is server 2, and to identify the location of a server, we use the same hashing SHA1 based on IP or name depending upon what best suit for us. So let's say in this case, we do SHA on the IPs of the server and find out which slot they will fit in, and we place these servers over here. Now we have S1, S2, S3, S4, all four servers placed on the ring. So how the consistent hashing distribute the load? It runs through the clockwise fashion. So right beginning from key 0 and it start running clockwise, and when it reach on a first server, all the keys up to that point will go onto that server. So 0, 1, 2 will go on server 1, 3, 4, 5 will go on server 2. Similarly, 6, 7, 8, 9 will go on server 3, and 10, 11, 12 and up to this will go on server 4. So now as you can see that load is distributed, we have the ring, and now talk about the problem where we need the consistent hashing and the problem we were facing in traditional hashing, and that was if a server is down. So let's say if server 3 is down, how this will work in this case? In this case, we are not using any modular and formula. What we are doing, we are using the clockwise pattern to allocate the keys onto the server. So server 3 is down, and you can see it was key 6, key 7, key 8, key 9. Those keys were on this server. Now when this server will go out, all these four keys will go on to next available server in clockwise, and that is S4. So now all these keys are moved to S4. Rest entire system is intact, and that's working fine. So we solved that problem. But if you notice here, once the server 3 is down, a huge workload is on server 4, while comparatively server 1 and server 2 are not too much loaded, which is against our, equally distribution load among servers approach. So what should we do? We have a way to do it. So I'm just taking out this thing because we already talked about server down scenario. So how it works actually, there is very interesting concept comes here in the consistent hashing, and I'm just taking out and making some space here, just trimming guys, and I'll be back. You know, reduce the size of these circles just to make some space on the ring. So what it does now, the concept comes here is the virtual node. What is virtual node? As per now, if you see server 1, server 2, server 3, server 4, they are allocated on a particular slot in this hashing ring. And in the clockwise pattern, they are holding all the keys which are coming before them. So it was pretty good so far. Now, what virtual node does, rather having a server in a particular slot and having only the keys which are coming before it, there are the virtual nodes of each servers, and those are distributed on this ring. So each server has the virtual nodes distributed or placed at different places in this ring. For example, server 4, it has, let's say, two. One is placed here, and let's call it VS4. Another is placed here, VS4, virtual node of server 4. Another is placed here. Similarly, server 3, that also has the virtual nodes, and they are placed on this ring. So let me place them, and I'll be back. So the benefit here we got is that servers are also not allocated on a particular location in the ring, because that was causing into non-uniform load distribution. So what we did, we have distributed servers also over the ring, by which there is like uniform distribution. And if a particular server goes down, its all virtual nodes will go out, and the keys allocated on this and its virtual servers will get allocated further to the next available server in the clockwise pattern. So if server 4 is down, if this is down, then actually all its virtual server will also be down here. So these all are gone, and now you can see the load, this key will go onto this server, Similarly, this key will go on to this server and so on. So all the keys are like uniformly distributed to other servers. So yeah, that's what the consistent hashing is, guys. I hope this will help you to understand. So thank you so much, guys. And please don't forget to subscribe my channel and see you in another session. Thank you.